Good morning and welcome to Maths with Miss live in London, our summer special. We are on lesson 13. Sadly, I don't know if you can see, but sadly, I don't know if you can see, I'm home alone. Look, I've got no Rose today, I'm afraid. She's at a summer camp at school today. So it's just us, I'm afraid. But that's okay, because she will be back before the end, and I guarantee on the last session on Friday, she will be with us and she's going to be pulling off the most magic trick yet, hopefully, with the cards. So anyway, let's get started. You've got your pens, you've got your paper, you've got your, well, you haven't got your calculator because you don't need one of those, and you've got these amazingly fabulous brains that we're working with. Now, I was having a little chuckle this morning that there's a little bit of competition going in terms of who can get that first comment in, and Chloe won today with the first comment of the day, and Code Wrecker, Alex, I think. I still have to make sure I can match up the names with the codes. I'm afraid you didn't win. And good morning to Jathajan, and good morning to Arib. I am not sure if Arib has been on before. I think this might be your first time, in which case, welcome. How fabulous to have you here. I've got a few shout outs before I get started. I have Joshua, Peter, Georgia, Chloe, Matada, Emily. Good morning to all of you. I've got Jathajan, Hamza, Zachary, Rose, not my Rose because she's at Multisports today, Nadia and Alex. And I've just got a Harper as well. So before we start, hold on. Look, somewhere on the floor. Where are you? There she is. Look, so we've got a new addition to our classroom. We've got a little Harper there. Say hello, Harper. Harper's been for a long walk, so she's very tired. Okay, right, so let's get started and have a little quick look, a little reminder of our takeaway challenge that you were left with on Friday. Okay, if you've not had a chance to look at it, you can pause it now and have a go, for those of you who have. Now, I'm not sure how many different solutions there are out there. I've got quite a few just here. I'm going to explain one of the concepts of when you get started, how you can look at breaking it down without hopefully stepping on the dog. So if we're looking at making 100, I'm going to think, how can I get 100 out of maybe some of these numbers, not necessarily using all of them and then playing around. So when I started looking at this, I thought, well, if I put my 4 and my 5 together, that would give me 20. If I put 8 and 9 together, okay, that would give me 72. Oh dear. Oh dear, you can tell it's Monday morning, can't you? 20 plus 72. So I've got 92. And I've used my 4, my 5, my 8, and my 9. So I've got to get 8 from the remaining numbers. The remaining numbers I've got are 1, 2, 3, 6, and 7. Okay? So now let me have a look at it. And maybe what I could do is you have a little play around. 3 multiplied by 6. Let's try that. 3 is too big, isn't it? Because I only want 8. But I've given myself 18. So now I'm 10 too big. But I've used the 3 and I've used the 6. And I've got to reduce my total by 10. So now, look, I can just take these all away. So subtract 7, subtract 2, subtract 1. So that's the same as subtracting 10. Just get rid of this, make it a bit neater. Let's just double check and make sure it works. 20 plus 72 is 92. Or sometimes, remember how we pair things together, we use our number bonds to make it easier. So maybe I'd add these two first, because that would give me 90, 110, and then I subtract my 10 to get 100. Okay, there are lots and lots of different solutions to this. You could do one where you literally just do, so that's solution 1. Solution 2 is 9 multiplied by 8, and then you literally just add on the remaining numbers. Is that right? Because that gives us 72, and all of that added together gives us 28. And well, I've written up 5 solutions there, so maybe if you can see those, okay, because I'm not going to have time to write them all up. But there might be some more. So if you've got a different solution, then let me know, okay? Pop it on the chat or pop it on the Facebook page, and then I can see some of the other potential solutions that are out there. Excellent. Okay, well, let's start with our 30 questions. Let's get a little bit of music going. It is over to you. You have 2 minutes. Thirty seconds remaining. Part 2. Thirty seconds remaining.
30 seconds. Okay, your time is up. Let's go through some answers. I have no, don't know where my pointy stick's gone. Here we go. Right, so we have question 131, question 236, question 3, 204, question 4 is 73, question 5 is 18, question 6 is 9, question 7 is 64, question 8 is 9,920, question 9 is 3, and question 10 is 3.1. Moving on to part 2. Okay, question 1 is 3.73. Question 2 is 3/10. Question 3 is 2. I will also accept -2. Question 4 is -6. Question 5 is 1. Question 6 is 5. Question 7 is 117. Question 8 is 14. Question 9 is 18. And question 10 is 24. Part 3. Question 1 is 4. Question 2 is 9:08 p.m. Question 3 is 10:14 p.m. Question 4 is 3. Question 5 is 50. Question 6 is 15. Question 7 is yes. 7 is a factor of 98, and therefore yes, 98 will be a multiple of 7. 98 is in the 7 times table if you go high enough. Okay, it's actually 14 multiplied by 7. Question 9, the value of 2 cubed is 8. And question 10, an equivalent fraction to 8 over 3 if you expand it, multiplying the numerator and denominator by 4, gives you 32 over 12. Excellent. Thank you. Let's start with our challenge question 1. I've just put that up. I've got some scores in the chat so far. I've got Chloe, who has got 15 out of 30. Thank you very much for the feedback that you could read it fine. It was obviously just my system playing up here. Jathajan has got a full house, 30 out of 30. Absolutely fantastic. Any other scores, pop them in and I will, 18 out of 30 for Areeb. Well done, Areeb. And I will pick those up later. But here is your challenge question 1.
Right, how are you getting on? Pause it if you need more time. Just okay. So we've got an answer coming in from Misfit. Okay, very good. Well, we'll have a little look at that in a moment. I was going to see if anybody needed any more time. What I'd suggest, if I just flick this back around, if you need more time, you can just pause it now there. Okay. Otherwise, let's have a little look and see, because although Misfit's got an answer and it's really hard in the chat, I don't expect you to give me an explanation in the chat, but we want to work out really how to do it and why it works in a certain way. So the first thing I would probably do is just write all the numbers down. Hopefully you will have sketched a circle. That helps you visualize what we've got to do to get the solution as well. Okay, and then we need to play around a little bit. So for example, if I added up the first 6 numbers, then we definitely wouldn't get the same answer as if I added up these 6 numbers. Okay, maybe we could add up all the numbers and then divide by 2, because that would tell us the sum of the numbers up here and the numbers down here, or wherever it breaks. So we could do that. So if I added all these numbers together, I would get 78. Okay, so if I sum all of those numbers, I'm going to get 78. Now, if you need a little bit more time at this point, then again, please feel free to pause it. Okay, this is not a race. None of these challenge questions are races. We would spend ages discussing them in a lesson. All right. But if we've now got to the point that we know that they all sum to 78, and half are going to be on one side of the break and half are going to be on the other side of the break, I can just do 78 divided by 2, which is going to give me 39. So now I've got to find 6 numbers that sum to 39. Now, the way I did this, okay, brilliant, brilliant. Misfit's given me some more explanations, which is absolutely fantastic. I love it. So let's have a little think and see if we split it perhaps. We know that if we add those 6 numbers and those 6 numbers, we're not going to get 39. But what if we took these middle 6 numbers? We're probably in our heads maybe thinking a little bit about maybe even averages here, but you might not know that you're doing it. Pick these 6 in the middle, and then you've got the 3 smallest ones and the 3 biggest ones. Would they give the same number? Because what we're doing effectively is we're pairing 1 and 12 to give us 13. We're pairing 2 and 11 to give us 13. We're pairing 3 and 10 to give us 13. We're getting 3 lots of 13, which gives us 39. We're pairing 4 and 9 to give us 13. 5 and 8 give us 13. And 6 and 7 give us 13. Okay? So what we've done by pairing these numbers together, we know that the break has got to put these 6 numbers together. So 4, 5, 6, 7, 8, 9 has to be together. And 1, 2, 3, 12, 11, 10 go together. So exactly as Misfit said, between the 9 and the 10 and between the 3 and the 4. Well done. Okay, let's move on to challenge question 2. Just going to give you 20 more seconds. Don't forget to sketch it out. Okay, again, pause it if you need a little bit more time. Actually, I need a little bit more time. I'm still drawing it up on the board. Okay, so there you go. There's my pentagon. I've got P, T, S, R, and Q. And then I've got 2 lines. And sometimes you'll find that as you draw it, it helps you visualize what the solution is going to be. Okay, I know we've already got one solution. Yeah, okay, from Miss Vic, who's going into year 11. I love the fact that you're on. I hope you're getting something out of it. Maybe some things you're finding a little bit easier, because I've got some kids who are only in years 5 and 6. But I've got that whole spectrum, which is amazing. And I have still got a couple of tricky questions coming up. Right, let's take a look at this one. So what we need to do is we need to make sure that we go over each line once, but only once. So if I started, for example, at T and I went round, I'd get myself into a bit of a mess, wouldn't I? I'd be able to get to R and I'd be able to get back to T, but I'd miss out that bit there. That is really rubbish, isn't it? You can't see it very clearly. Maybe if I bring it forward, you can see it a tiny bit better. Whoops. Okay, so you can see that if you started at T, you couldn't get a solution. And the same would apply if you started at Q, obviously, because it's symmetrical. What about if we started at P? Let's try that before we look at what Miss Vic's done. Okay, so if we started at P, for example, we'd come down and down. Okay, so then again, you've got a choice. You could either go across. Okay, maybe we'll try that. And then up, and then down, and then round. But again, we can't get back to either R or P to do this final line. So that doesn't work. So what you might be noticing is if you start at one of the vertices that only has 2 ways to go, or P, which had 4 ways to go, you can't get a solution. What happens if you try down here? Note here that you've got 3 different choices from vertex S or vertex R. So let's try this one. We're going to go up. We're going to go round. Then we could, should we just label, put arrows on so you know which way you're going? Then we could go down. Then we could go across. We could go back up, back down, and back round. So we can start at S, and because it's symmetrical, we can start at R as well. Okay, so let's just write, I'm going to go back to my black pen, so hopefully you've got half a chance of reading it. So we started at S, we went to T, we went to P, from P we went to, what did we do? We went back to S, then we went to R, then we went up to P, across to, let's go up here, across to Q, and then finally back to R. Okay, so hopefully you can see that all right. We are nearly done. We've got a couple of dingbats. And then we've got your takeaway challenge. Any other comments I need to? Doesn't matter what your shape looks like. It doesn't have to be. That, to be honest, that's not too bad, is it? It's clearly not a regular pentagon because it obviously Q should be up here to make it symmetrical. But you get the idea. When you're sketching something, you're just sketching it so it represents something to help you. Okay, it doesn't have to be completely perfect. It would take us about, I've done it in a lesson, it takes about half an hour to draw a perfect pentagon. It's quite a complicated thing to do. Okay, here is your first dingbat. You guys are on fire today. You are flying through these. You're absolutely right. Oh, I had treehouse and that's disappeared. I love that answer. Okay, but it's not a house. It's actually meant to be a factory with the Y taken off. So factor and then a tree. Factor tree. There you go. Second one coming up in a moment. I'm going to pause you there because Chloe has got the, it's not a trick question. It is indeed half. So Ariba's got it. Chloe has got it. Well done. Half. Okay. Here is your challenge question, your takeaway challenge. Now, this question is tricky. So I'm going to just spend a minute maybe giving you a little bit of a helping hand before you start. It's half. It's not fraction. It's half. It's half of a fraction, so it's half. All right. So have a quick look at this, and then I will just mention a couple of things before we go through it on Wednesday. Right, so just, again, you can pause it and write it down. I'll put it back up in a moment. So obviously you can look at using trial and error for a question like this. You can look at using some of the rules that you know, some multiplication rules that you know, which I'm just going to remind you of in a minute, or you can do a combination of both. Okay, so let's just ping round so you can see the question. All right. So you've got 3 digits that you need to find. And the question says that the number is divisible by 1, 2, 3, 4, 5, 6, 7, all the way up to 12. All right. Now, the fact that the number is divisible by 1, I probably don't care about that. I can probably disregard that. But the fact that it's divisible by 10, well, that's quite valuable, isn't it? Because that tells me what one of the digits is. Okay. So then just think about some of the other facts that we've learned when it comes to multiplication and to divisibility. So, for example, I think you should know now that if you add the numbers together in a number, it can tell you if it's divisible by 3 or not. So if I've got, let me just show you quickly here. If I've got the number 123, if I add my digits together, I get 6. So I know that it's in the 3 times table because 6 is in the 3 times table. Okay, all right. And if I did 1, 2, 3, 6 as mine, I'll do that one in a minute. Hold on. Let's do this one. If I did 1,233 and I added the digits together, I would get 9. And that would tell me that it's in the 9 times table. Okay, so that's in the 9 times table. So that might help you. All right, so you know what it is if it's in the 10 times table. Remember, if you've looked at the 10 times table, maybe you don't need to worry about the 5 times table. If you've looked at the 10 times table, maybe you don't need to look at the 2 times table. So think about the important ones that you need to focus on. It's a tricky question. And what was that? The answer begins with 3. Thank you, Chloe. All right, so okay, and we've worked out that the last digit is 0. Excellent, okay, because it's in the 10 times table. Well, now it's over to you. Have a go. I'll give you the solution on Wednesday. Good luck. Have a fantastic couple of days. Looking forward to seeing you Wednesday. Bye-bye.